Okay. Today I want to introduce you the tension, uniaxial tension test, and the indirect tension test, and the biaxial compression test and triaxial compression test. We will start from the direct tensile strength test. This will be a typical test like the metal. If you have a metal, if you want to measure the tensile strength of the metal, you will try to do the same testing. But for rock specimen, that will be more difficult than the metal. So the most important things, you cannot make the rock specimen damage because of you want to put in apart and you apply the holder to hold them. You cannot make the rock specimen damage. For metal, you don't really have this kind of problem or difficulties. This will be one possibility to install the specimen like this, and you can have some glue, very strong cohesion. You can make this fully coupled with this. Then you will put apart from here and from here. This will be kind of a ball bearing. Then you don't really produce any moment on this specimen. Then some glue have a very high strength. When I was the PhD students, one of my junior classmate, his name is the king of the glue. Why? Because he trying to test many different kind of glue to doing the test like the direct tensile strength, because they need to have a very strong cohesive here. So when we discuss, we will not make him angry. Otherwise, he will put the glue on our mouth. Then we cannot open our mouth anymore because they have a very strong cohesion. Okay, so if you pull this rock specimen successfully, pull them apart, then the load divided by the area will be the tensile strength. That will be a very simple idea. But it will be a little bit difficult to doing this kind of test. Or you can try to design your specimen like a so-called dog ball shape. Then you can put the holder here, and put this apart. Because you have a small diameter here, then that will be more easier to make them broken into two pieces. Okay, that will be another possible design to doing the direct tensile strength test. The other alternatives, we will have two very important indirect tension tests or tensile strength test. This will be the so-called 4-point bending test. If you apply a load here, then this load will transfer to these 2 points. If you have this 2 points, apply a load, then you will have an inverse load in this direction. If we call it the P divided by 2, P will be the load, and this will be the P divided by 2. These two will be the total load. Understand? And here you will have a P divided by 2, and here you will have a P divided by 2. Then this will be a typical problem for material mechanics. When you are the second grade for the undergraduate program, 你大二的时候学的财力就在做这件事情。Did you still remember this? You will draw the shear diagram and draw the moment diagram, right? It will be like this. you will have the moment diagram like this, and you will have a shear diagram like this. In this part, you will have the maximum shear stress at these two segments. Here, you will have a zero shear stress. Here, you will have an increasing moment, and you will have a maximum moment around here. Then the moment will decrease from here to here. I already introduced this to all of you. If you apply a bending, if you have a moment, then in one side you will have a compression stress. On another side you will have a tension stress. From the place where you have a tension stress, if the tension stress large enough, then you will have a tensile failure. You can imagine, when you apply a load like this, what happened? What happened? This beam will begin. If you load like this beam will become like this. When the deflection increase, finally you will have a fracture at the center. And the fracture will propagate. And finally the beam will, boom, broken. Start from the bottom where you have a tension stress. Okay? Then all of this will be the material mechanics. This will be I of this beam. And this will be the stress along the beam. Okay? If you have a different moment, then you will have a different stress. Then this will be the kind of failure stress. Okay? Make the tensile failure start to propagate. So this will equal to this, and it will be function of the load applied here. So that means if you have the diameter of the beam here, and if you have the length of this beam between this here and here, and when you trying to do the test, you will get the P, then you will get the tensile strength. Understand? This will be the major one when the beam broken, and this will be the geometry of the beam. So the tensile strength can be calculated like this. I have an advanced question to ask you. What is the difference between the 3-point bending test and the 4-point bending test? Why we need to put the loading system like this? To put the stress here and to put the stress here. The load here and load here. Why not provide a P concentrate at the center of the beam? You can make the beam failure. It will be the same, right? That means to make this deflection, the 4-point test, you will apply a load here and apply a load here and make it deflection. Why don't we just put the concentrated load at the center? You can make the beam broken as well, right? Why not? You can see the diagram if you have a diagram like this. If you have the concentrated load at the center, then what happened to the moment and shear diagram? There will be a triangle. Goes up to the maximum value, going down to the minimum value. Okay? So around here, the moment will not really stable. It will vary at the location. And the other important things, if you have a concentrated load at the center part, then what is the distribution of the shear stress? There will be the maximum shear stress go all the way to the right hand side to here and drop down to another direction. So almost nowhere is zero shear stress. Everywhere have shear stress, except exactly the location where the load applied. When you're doing the test, it will be a little bit difficult to get the really failure location and the loading location. Then you were influenced by the shear stress. And the moment is not stable. That will be the reason why we designed the 4-point bending test. Did you understand? Okay. The second one will be the Brazilian test to get the tensile strength of rock spacement. We will cut the rock spacement into a disc, like the figure shows you. You will have a thin thickness of this disc. When we apply a load like this, we can calculate the tangential stress and the radial stress at any location within this disk. This will be the polar coordinate system. Did you understand the tangential stress and the radial stress? We will mention this later at the lecture 4. A lot of things related to this. 这极坐标系统啊，所以你有切向应力跟径向应力，所以不是它的意思就是跟 sigma x、sigma y 是一样的意思，只是它是极坐标系统。So this will be the similar like to sigma x and sigma xx and sigma yy. It's totally the same. However, the sigma xx, sigma yy will be the rectangular coordinate system. This will be the polar coordinate system. That will be the same idea. So you will have a tangential stress tangent to the radius. Then you will have the radial stress parallel to the radius directions. The tangential stress will be the main parameters we care about. So we can calculate the stress at any location. This will be some derivation, analytical solution from the elastic mechanics. You can easily to get this kind of solution. Okay. And the radial stress will also be function of the location. And of course, this alpha will be how large the load applied to this disk. Understand? This will be alpha and this will be alpha. And the total area will be 2 alpha. It will be extremely difficult to really put the line load. Did you understand the line load? Using this as an example. You need to really have a concentrate loading location where the thickness almost approach to 0. That will be extremely difficult. So usually the load applied to here and here, they will cover certain angle. I will show you. And this will be the alpha. The radial stress and the tangential stress will be function of alpha as well. Okay? So the only difference between the tangential stress and the radial stress will be this will be minus, this will be plus, this will be minus, and this will be plus. That will be the only difference. If the alpha approach to 0, this will be ideal case. For real testing program, that will be difficult. to produce this kind of loading condition. Okay, under this condition, the tension stress will be the maxima when R equals to 0. That will be the center of the disk. Understand? At the center of the disk, if you insert all of the parameter into the previous two equations, then you can get the sigma theta will equals to this. And the sigma R equals to 3 times the tension stress. This will be the stress when the disk broken into two pieces. When you apply the load, then you will have very large tension stress, especially at the center of the disk. Then when your load large enough, then the tension stress can pull the spaceman into two pieces. During this time, this tensile strength will equals to this. If you have this, if you have the geometry of the disk, this will be the diameter of the disk, this will be the thickness of the disk, and this will be the testing results. You will have a maxima P, concentrate load, maxima P. This will be major parameters. Then you can get the tensile strength. When the rock broken, you do have the compression stress acting on the center of the rock, of the disk. That will be roughly 3 times larger than this. Okay? But usually, the compression strength will roughly 10 times larger than the tensile strength. So the disk cannot happen compression failure. Understand? 在这个圆碟的中间，张应力是压应力的3倍，但是通常压应力会是张应力强度的10倍，所以坏一定是张应力破坏会先，可以了解吗？ At the center of the disk, the tensile strength was 3 times, the compression stress was 3 times larger than the tensile strength. However, the compression strength usually larger than the tensile strength 10 times. So the failure will be controlled by the tensile failure. Okay? I will complete the introduction of the Brazilian test. I already heard about that. This will be the distribution of tensile strength. Sorry, not tensile strength. It will be the stress distribution along the radius for the sigma theta, tangential stress, the red curves. This will be the sigma R. And the brown one will be the shear stress along the radius from here to here. Okay? You can see here, if you have a -1, then here, there will be 3. It means the compression, the radial stress will be positive. The tangential stress will be negative. So the radial stress will be compression, and the tangential stress will be tension. And the absolute value of the radial stress will be 3 times larger than the absolutely value for the tangential stress. 所以各位可以看得到，就是切向应力、径向应力的绝对值会是切向应力的绝对值的3倍。刚才我讲过了，但是因为压力强度通常是张力强度的10倍，所以坏一定是坏在张力破坏，不会坏在压力破坏。Okay, this will be the case when the alpha equals to 0. There will be the perfect loading condition. However, we are not really have this kind of ideal condition. So the true condition will be like this. you will have a concentrated load like this, and you will have a platen here. Usually the platen will be a little bit curved. Understand? Follow the curves, the curvature of the disc. Then, when you apply the load here, then you will have alpha around here. Understand? Under this real condition, this will be idealized condition. Under this condition, the tangential stress will like this. This will be the difference around here. If you have alpha here, then the stress and on the edge will become compression but not tension. Only concentrate load, only line load, you will have a perfectly tension stress on the tangential direction. OK， 只有完美的现在重，你才会沿着这一个 disc 的这个垂直的方向，在正中心这里会有一个完美的张应力。但是如果你要是有一个荷重是这样子，不是一个真正的线荷重，这个是事实上的实际的实验的方式。你的这个切向应力在靠近你的试体的边缘，靠近荷重的这个地方，会从张应力转成压应力。不过这一个无伤你的试验结果，因为你的实验还是会破坏在这一段。OK， and this will be the shear stress, and this will be the radial stress. Okay, that will be not influence the data analysis because we care about this part. It's still the same. This part will be the same with this kind of line test. That will be the same. Usually the Brazilian test will give a little bit higher tensile strength than the direct tension test, because the fracture within the spaceman will have larger influence on the tensile strength of rocks. For the direct test, 张力实验受到那个里头的一些原有既有的裂隙受到那个影响会比较大，比巴西实验会大，所以使得就是直接张力实验得到的张力强度会比巴西实验得到张力强度稍微小一点点。Okay, and I will give you a lot of the questions rise from the national profession test, including the applied geology and the geotechnical engineering. 这大地技师，然后这个应用地质技师都会考。I will not repeat this. I just trying to show you. You can read this by yourself, especially for the local students. A lot of questions like this asked in the national professional examination. 好，各位很快的看一下，各位都知道，大概会知道我在这些投影片是在做什么。这些投影片其实是田永明田老师准备的啦，我是替他上，那我可以理解田永明老师在告诉你们这些问题，这些都是国家考试的问题。Okay, for the extension reading, you can look at those to learn more about the Brazilian test. Okay, I will